So let's start with number 14 here. It's asking us to find the exact value of the composition. So just like the end of the last video, we still have the same notation where we're doing cotangent and then arcsine, and so we need to find this piece first. And just like with the unit circle, we are thinking to ourselves that we would like an angle, or theta, that's restricted to quadrants 1 and 4. Now unfortunately though, -4/5 is not on the unit circle. So when we have something not on the unit circle, I would rely on something else we know pretty well, a triangle. So let's draw a picture over here, and we need to decide which quadrant we're drawing the triangle in. If the ratio of arcsine is negative, and we're restricted to quadrants 1 and 4, we need to draw the triangle in quadrant 4, based on the fact that the y value is negative there. So what we're going to do is put the reference angle in the triangle close to the x-axis, because that's the definition of a reference angle. We then know that sine is really opposite over hypotenuse, so we can label this triangle accordingly based on our knowledge here. The opposite side is 4, the hypotenuse is 5. Which one of these two has to be negative based on the quadrant? Well, the 4 does, because the y's are negative there. This is a Pythagorean triple. This would be a 3 here, and this is positive because the x's are positive in the 4th quadrant. So what's interesting about these problems is that I never actually find theta. I just use this notation to help me draw a triangle, because then my goal is to find cotangent of this angle. So what you can think about is that this triangle over here represents theta, because it's right here. So now we're trying to find the cotangent of theta. And so we could just use the triangle to do that. We could say, I know that the tangent of theta is opposite over adjacent, which is -4/3, which means that the cotangent is really the reciprocal of -3/4. The same goes with number 15. Even though everything's symbolic, what we can do is think about quadrants first, because this is definitely not on the unit circle, this angle, or this ratio for sure. So let's draw a picture. So if we're thinking about it, we're trying to find an angle, arctan. And arctan, the angle, or theta, is restricted to quadrants 1 and 4. Because x and t are both positive, I don't see any reason why we can't draw the triangle in quadrant 1. We would again put the reference angle next to the x-axis. We think about what this means. Arctan, the ratio is opposite over adjacent for tangent. So I know that the opposite side is x and the adjacent side is t. And even though everything's symbolic, what we could do is find the hypotenuse with the Pythagorean theorem symbolically. A squared plus b squared equals c squared. X squared plus t squared equals this unknown squared. So I will call that unknown question mark. And my goal is to get question mark alone. So what I can do is take the square root of both sides. So I'd get that the unknown hypotenuse is equal to the square root of x squared plus t squared. And remember in class we talked about that we cannot cross out the square root with the squareds because of that plus sign in the middle of the terms. So that means, and because we'd be breaking the order of operations, remember. So this hypotenuse is really equal to the square root of x squared plus t squared. So everything is still so symbolic. But remember, what we're really trying to find in the end is the secant of my angle, theta. And now that I have this triangle with theta here, I can find what secant is. Secant is the reciprocal to cosine. So cosine of theta is adjacent over hypotenuse, which in this case would be t over the square root of x squared plus t squared. This isn't the answer because I need to find the reciprocal. However, if this was the answer, remember in class I mentioned that you do not need to rationalize this. Mr. McCone and I are just worried about can you draw the triangle and get to this. The actual final answer here though is the reciprocal, which would be the square root of x squared plus t squared all over t. Let me write that more clearly over here. The answer is x squared plus t squared all over t. And we cannot cross out these t's, again, because this t squared is underneath the square root. All right, use your calculator to evaluate the trig functions around to 3 decimal places. So for part A, if I see secant, what I'm thinking about is cosine. I also notice that my angle is given to me in degrees. So make sure when you have your calculator that your mode is in degrees. So this was from, if anyone's interested, this was from the 3.11 video, Calculator with Trig Functions, if you ever want to go back and use it as a resource. What I would like to do on part A is write this differently into something we recognize. Secant is really the same as 1 over cosine, so we could think of this as 1 over cosine of negative 155 degrees. We can plug this directly into our calculator. Now before I get my calculator out, I want to point out to you that notice that I found the reciprocal of the function. I did not flip the angle. Think about it. Anytime you're doing the unit circle or using the unit circle, do you ever take an angle and flip it around? Let me show you. If I look at this unit circle, do I ever take a radian and flip it around? No. All I do is, if I'm finding reciprocals, I'm finding reciprocals of the coordinates or the ratios. So when you get to a problem like this, I remember I showed this in class, but I want to reiterate this. This would not be your answer. You never, never, never flip the angles. This is incorrect. What you're going to do is take the reciprocal function and keep the angle with it. So I paused the video for a minute to get the calculator out. So what we would do is just kind of plug and chug at this point. We would first need to make sure that our mode is in degrees. This one's not, so I have to change that. All right. Then we'd have to go 1 divided by the cosine of negative 100, didn't work. And if I do that, I get an answer of negative 1.103. Now if I look at part B, I think the reciprocal function of cotangent is tangent, which means this is the same as 1 over the tangent of 3 pi over 7. Notice again, I did not flip the angle, because the angle is always attached to the trig function. It's the trig function that flips or finds a reciprocal. So I actually tried to plug this in the calculator multiple ways, but here would be my suggestion on how to do it. First, I would make sure that your mode is in radians. Secondly, I would plug in 3 pi first so we can figure out what this angle is, because otherwise you're going to be dealing with a lot of parentheses. So I would do 3 second pi, press enter, divide that value by 7, and now we need to find the tangent of this answer that we just found in decimal form. So it would be tangent of second answer. So this right now is 4.381. So now we need to do 1 over this answer. So it would be 1 divided by second answer. And when I did that, I got the answer of 0.228. Now you could try to plug this in directly into your calculator with a lot of parentheses. And if you do and you do it right, you should get the same answer, but just please be careful. So my answer is 0.228. All right, the last type of problems. Given the following, solve for theta in radians on your calculator, round to 3 decimal places. Your final answers must be positive, and it must go from 0 to 2 pi, which means, like earlier, I'm going to have 2 answers, and my answers are going to be in radians. So, eventually, I'm trying to find an angle, so I will need to take an inverse of both sides. But before I do that, I want to think about what this problem is saying. This is saying that my x values are negative, which means at the end of the problem, before I take an inverse, the quadrants that the x values are negative are quadrants 2 and 3. So I know at the end of the problem, my answers are going to be in quadrants 2 and 3. But first, if I solve this and I take the inverse cosine, or the arc cosine of negative 0.75, in my calculator, make sure your calculator is in radians when you do this, you would get that your theta is 2.419. So what we need to do is think about what quadrant this is in. When I take an inverse, we are restricted to quadrants 1 and 2. So I'm either going to draw my picture in quadrant 1 or quadrant 2. Because the ratio that I started with is negative, I'm going to draw this angle in quadrant 2. And so here's what I have. I know that this angle is 2.419. So my final answers want to be in quadrants 2 and 3. Do I already have a positive angle answer that lands in quadrant 2? Yes, I do. So my second quadrant answer is 2.419. But again, x is negative in the third quadrant. So we also need to find this answer. And so we want our answers to be positive, so we want to find that angle. And notice, when I drew that, I went directly past 3.14, and so we're going to do 3.4 plus something eventually. But we first need to find what that something is. And everything has to do with reference angles. So if you look at this little green angle here, to find this piece, the blue angle is the 2.419 goes to here, but it doesn't quite get to 3.14. So if I want to find this little green angle, it would be 3.14 minus 2.419. So this little guy is going to be 0.721. The reason that matters is if I want to find the red angle, I'm going all the way around to 3.14, and then if this little guy is 0.721, this little guy is also 0.2721, because they're both reference angles. So to find my third quadrant answer, I would go past pi, or 3.14, plus the reference angle of 0.721, which will get me an answer of 3.861 for my other answer. So the only reason you use restrictions in these problems is to draw the original angle. Otherwise, you think about what the original problem said and what quadrants your final answers are in based on x's are negative. If I look at the next problem, same directions, 0 to 2 pi, positive angles. First, let's think about where are the tangent values negative. Tangent are negative. Tangent is negative in quadrants 2 and 4. So in the end, my answers will be in quadrants 2 and 4. Now first though, I need to figure out what theta is. So if I take the inverse tangent of negative 0.75, which again is the same thing as the arc tangent of negative 0.75, and I plug that into my calculator, I get that my theta in this example is going to be negative 0.644. So if I'm thinking about when I take an arc tangent that is restricted to quadrants 1 and 4, I have to draw my picture either in quad 1 or quad 4. Because my original ratio was negative, we're going to draw this in quad 4. So here's what the calculator gave us, negative 0.644. Now, my final answer is in 4, but we need to kind of rethink this a bit because this is a negative answer and we want a positive answer. So what I would do is draw the reflection in the first quadrant. So if this is negative 0.644, the first quadrant answer is positive 0.644. And if I want my answer in quadrant 2, I'm going like this. And notice that I'm going into the second quadrant. It is not quite reaching 3.14 yet. So we would have 3.14 minus this little reference angle, which is 0.644. So my second quadrant answer is pi 3.14 minus the reference angle of 0.644, and that would really be 2.496. And then if I wanted to find the fourth quadrant answer that's positive, it is already drawn here, but we have to go all the way around this way. And if I go all the way around, notice that I am not quite getting to this x-axis. I'm not quite getting to 6.28. So we would take 2 pi, or 6.28, and we would subtract the reference angle, 0.644, and that would be 5.636 for my other answer. So guys, the last example, I'm just going to show you the answers because I'm running out of time. So I'll pause now.